Problem number 39. It's a bunch of linear approximations. First thing that we have to approximate is this expression right here. For each of these parts, the very first thing that we need to do is come up with a function that we can plop in. So f of xy, in this case, so we have something raised to the negative first power times something raised to the fourth power. So let's go x to the minus 1, y to the fourth. And then we'll be plugging in, plugging in 5.01 and 0.97 in here for x and y. This is the function that's the function value you're trying to approximate, and it's close to 5 and 1. So, okay, we need f sub x, f sub y. The x partial derivative will be negative x to the negative second power, y to the fourth. The y partial derivative will be 4x to the minus 1, y cubed. Okay. Now let's plop in, this is 5.01 is about 5, 0.97 is about 1. So f of 5, 1 is 5 to the negative first power times 1 to the fourth. So that's 1/5. F sub x of 5, 1 is negative 5 to the negative second power times 1 to the fourth. So that is minus 1 over 25. And the y partial derivative here, evaluate at 5, 1, is 4 times 5 to the negative first power times 1 cubed. That is going to be 4/5. Okay, what can we do now? Now, okay, we can go ahead and do our linear approximation. So our approximation, L of xy, is equal to f of 5, 1, 1/5, plus the x partial derivative at 5, 1, so that's minus 1 over 25, times x minus the x value in question here, x minus 5, plus the y partial derivative is 4/5 times y minus the y value in question here, y minus 1. So then, to finish this off, L of 5.01, comma 0.97 is equal to 1/5 minus 1 over 25 times 5.01 minus 5 plus 4/5 times 0.97 minus 1. And this will be 1/5 minus 1 over 25 times 0.01 plus 4 over 5 times negative 0.03. Of course, we can simplify that if we want to, but I'm just going to leave it like this. Okay, the second part here should be very similar. Our f of xy, so we have something over something here. So let's go for x over y. F sub x is going to be 1 over y. F sub y will be minus x over y squared. This is going to be close to 4 over 8. So f of 4 comma 8, 4 over 8 is 1/2. F sub x of 4 comma 8 is 1 over 8. F sub y of 4 over 8 is negative 4 over 8 squared, so that's negative 1 over 16. So I'm just going to go ahead and kind of jump straight to the conclusion here, which is that 4.1 over 7.9 is about equal to 1/2 plus 1/8 times, we go from 4 to 4.1, 0.1, minus 1 over 16 times we're going from 8 to 7.9, so the change there is negative 0.1. Again, for this one, you can go ahead and simplify that if you want to. You can simplify this if you want to. It can be instructive to compare the approximation that you get to the true value that a calculator would give you. We'll call that good on these two parts so far. The final one, let's see here. F of x, y. So we have something squared plus something squared under a square root. So x squared plus y squared. That looks like this will be our function in question. Plug in 3 and 4 in for x and y. Will be our f of 3 comma 4. Square root of 3 squared plus 4 squared is 5. Okay, partial derivatives. The x partial derivative will be 1/2 times 2x times x squared plus y squared to the minus 1/2 power. So that's x times x squared plus y squared to the negative 1/2 power. The y partial derivative will be y times x squared plus y squared to the minus 1/2 power. The x derivative, partial derivative, evaluate 3, 4 will be 3 times x squared plus, 3 times 3 squared plus 4 squared to the negative 1/2 power. So that's 3/5. The y partial derivative, evaluate 3, 4 will be 4 times 3 squared plus 4 squared to the negative 1/2 power. That's 4/5. Okay, so then this expression here is approximately equal to 5 plus 3/5 the x partial derivative here times the change going from 3 to 2.99 is negative 0.01 plus 4/5 times the change going from 4 to 4.03 is positive 0.03. So again, crunch this out. We can just leave it as this, and this is the final answer, and we can crunch it out to compare if we want to.